Alrighty, so we're going to continue working through these exact values. And in this case, we're going to be looking at exact values further than that first quadrant. So I want to know all the exact values of 45, 90, 135, 180, all of the multiples. So the values we're going to be interested in is going to be 0, 90, 180, ... going up in 90s, the 30, 60, 90, well, 90 we've already written above there, so the next one would be 120, 150, ... and then we also want to know the 45, the 9, oh, we've already written 90, so the 135, ... So these are going to be all of the values we're going to be looking for, and their radian equivalents, which is going to be 0, pi on 2, pi ... This one's going to be pi on 6, pi on 3, 2 pi on 3, and then 5 pi on 6. And you're unsure of that, write out all of your 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. See how they simplify. And for these ones, pi on 4 and 3 pi on 4. Because depending on which family you end up in is going to depend on which you're going to be using. We're going to be using the unit circle to work out those values. We're going to be using the 1, 2, 3 triangle for these guys. And for these ones, we're going to be using the 1, 1, root 2 triangle. So it just depends on which information we've been given. Let me write the 1, 2, root 3 properly. And I'll flip this one around for convenience. Alrighty, so the first one is 5 pi on 6. So it's going to be in the second family that we wrote up there. And in particular, we're going to need to draw it. The more accurate you draw the circle, the easier it's going to be. X, Y, and in particular, what are we looking for? Cosine of 5 pi on 6. Well, 6 pi on 6 would be half a rotation, which would be over here. So we're nearly there, but not quite. So that is 5 pi on 6. Now, once we get here, we want to work out what the reference angle is. And the reference angle we're looking for is actually this angle in here. And we can work out that angle by saying, okay, well, this is going to be equal to cos of pi minus 5 pi on 6. And you have a whole thing and you take off 5/6 of it. You're left with the cosine of pi on 6. But we have to be careful because this only works depending on which quadrant we're in. Okay? This is the all quadrant. This is the station sine quadrant. This is the 2 tan quadrant. And this is the central C quadrant. So since we're in the sine quadrant, that means cosine is going to be negative. So we need to make sure that based on the fact of which quadrant we're in is going to change the sign. So this is going to be negative cos of pi on 6. Pi on 6 we can work out by using our triangle, this one in particular. Cos is going to be adjacent over hypotenuse, which is going to be negative root 3 on 2. Alrighty, let's have a look at the next one. So, draw in our unit circle. 4 pi on 3. Well, 4 thirds is actually more than 1. So it's actually going to be down in this quadrant down here. That's where the angle is going to be. 4 pi on 3. Where do we get the reference angle? Well, we always draw the reference angle towards the x-axis. Okay, so we need to work out what that angle is. All stations to central. We're in the tan quadrant, which means that this sine value is going to be negative. And how can we work out that blue angle? Well, it's going to be 4 pi on 3 minus pi. So this is going to be sine 4 pi on 3 minus pi, which is minus sine of pi on 3. Now, once again, we're using this triangle, but we're starting from perspective of pi on 3 as our angle, and it's going to be opposite over hypotenuse, so it's going to be root 3 on 2. So it's also negative root 3 on 2. Alrighty, interesting how a lot of these things actually go through. Now, continuing forward, we've got the sine of 7 pi on 4. So 7 pi on 4, well, that's actually nearly 8 pi on 4, and 8 pi on 4 is actually, so 7 pi on 4 is going to be in the 4th quadrant. So it's going to be all the way out to here. Let me draw my circle in. I do like my circle. And we have x and y. Because it's nearly 2 pi, right? Because 4 pi on 4 would be 2 pi. So we're nearly at 2 pi. All stations to central. The reference angle we're looking for, draw the angle towards the x-axis. And because we're in the cosine, it's going to be negative, because sine's going to be negative in the cosine quadrant. And it's going to be the sine of 2 pi minus 7 pi on 4. 7 pi on 4 off that is going to be minus sine of pi on 4. New triangle, the 1 root 2. And both these angles are pi on 4 and pi on 4. Doesn't matter which one we use as our reference angle because they're identical. Sine is going to be opposite over hypotenuse, so 1 on square root 2, so minus 1 on square root 2, or minus square root 2 on 2, depending on your preference. It doesn't really matter, but it's good to know that these two quantities are the same. Let's continue, but this time, let's do it with tan. So for these ones, we're going to be doing the exact same thing, but in tan. So once again, draw your angle. Alrighty, well, tan 4 pi on 3. 4 pi on 3 is going to be in the 3rd quadrant. It's more than a pi, but less than 2 pi. It's going to be down here. And that is, in fact, the all stations to central. That's actually the tan quadrant, which means that it is going to be a positive tan value. Alrighty, because we're in the tan quadrant, tan is positive, and that means that we just need to work out the reference angle. Well, we've traveled pi on 2, so we just need to work out that reference angle, which is this one here. So it's going to be 4 pi on 2 minus pi, which is going to be equal to the tan. Oh, that should be 4 pi on 3. It's going to be pi on 3. If you're unsure about any of this fraction magic I'm doing, you can do the fraction stuff slowly. I'm just quick at it. So please feel free to use the fraction stuff slowly. Alrighty, and since we're interested in tan of that, it's going to be opposite over adjacent, opposite over adjacent. So the square root of 3 on 1, which is just the square root of 3. Remember, it's positive because it's actually in the tan quadrant. Let's do this last one. Unit circle. That's 5 pi on 6. Nearly a whole pi, but not quite. And the reference angle, all stations to central. It's in the sine quadrant, which means it's going to be negative. And it's going to be the tan of pi minus 5 pi on 6, which is going to be minus tan of pi on 6 Oh, so same triangle as before, and it's tan, which is opposite, over adjacent, which is negative 1 on root 3. And similarly for the 1 on square root 2, we sometimes normalize this by multiplying top and bottom by square root of 3. And we get negative square root of 3 on 3. And just as a reminder, either answer is perfectly correct. You don't have to leave it as square root of 3 on 3. 1 on square root of 3 is used almost as frequently. Alrighty, so that is how we can generate any answer to this. I'll see you in the next one. Goodbye.